Alright, in this video we're going to take a look at the beginnings of quadratic functions and their standard form. A quadratic function makes a graph whose shape, this kind of bell shape, is called a parabola. And the basic way that we get there is y equals x squared, and then we have a bunch of transformations that look like that moved around the graph. And if you want to look more at that, watch the video on transformations. We have couple things. We have x-intercepts. The function will cross the x-intercept one time, like this one, our y equals x squared, twice, or not at all. Has only one and always one y-intercept. There's going to be a y-intercept no matter what we do, but there's only one of them. There is what's called the axis of symmetry. The axis of symmetry is a vertical line through the vertex, because what I want you to notice is this bell shape is in two perfectly equal halves. So if we have something like this, we could fold the left side over that gold line and we get the right side. The vertex is the place where that direction changes. So right there where we go from going down from left to right to going up again. And that is also the maximum or minimum value. This one has a minimum because it's the lowest point on the graph. The other version of a parabola where it's been flipped upside down, like this one, is the opposite. So I'm actually going to start with that. Because it's going upside down, the vertex is the maximum point on the graph. The vertex here is the point -3, +4. So just, tell us where that is. The axis of symmetry is, since it goes right through the vertex, it is a vertical line. And so we know all vertical lines have the form x equals something, and it would be that coordinate of -3. The y-intercept here is 0, -5. We see that. The x-intercepts here are at -5, 0, and -1, 0. So there are two in this graph. The last one had 1 at the origin. You can have some with no x-intercepts. Okay? There are rules if you don't want or can't or shouldn't graph it. If you have a standard form, we say that it is ax squared plus bx plus c equals f of x or y, of course. This is similar to a linear function, capital AX plus capital BY equals capital C. So it's a similar version, but not exactly the same. Okay. The vertex we have a formula for if you don't want to graph it. H is the vertex. You may remember that from our function transformation video, what that looks like, is -b over 2a. So this -b is this guy, a is this guy. And then whatever you find from that, plug it into the function. F of h gives you the y-coordinate of the vertex, which we call k. Axis of symmetry is x equals h. Maximum or minimum is k. Maximum if a is less than 0, so if a is negative. Minimum if a is greater than 0, because then the graph would open up. If a is 0, it's not a quadratic, and none of this applies, right? All right, let's do one. Vertex. We've got a is 1, b is -8, c is 14. H, -b over 2a, -8 over 2 times 1. Negative is +8 over 2 is 4. K equals 4 squared minus 8 times 4 plus 14. I'm just going to keep going sideways because I'm otherwise going to be out of room. 16 minus 32 plus 14 is -2. So my vertex is 4, -2. Okay? -b over 2a, get what you get. That's the x-coordinate. Plug that into the function, and you get your y-coordinate. Again, If you want to use a calculator to help you find k, that's fine. Axis of symmetry is always x equals h, so that would be x equals 4 in this case. The maximum or minimum value is k, which would be -2. And because a is +1, this graph would open up, and it's a minimum. Right? Okay, you guys do this one. Pause and hit play when you've got a solution. All right, our vertex in this practice problem is -2, 3. Negative b over 2a is -4 over 2 times 1, which is -2. Plugging that into the function for k, I get 3. Axis of symmetry is x equals h, so that would be x equals -2. And the maximum or minimum value is k, which is 3. And because a is +1 again, it is a minimum value. Thanks for watching this video on Introduction to Quadratics and their standard form.